Good day everyone. For today's video, I will be discussing the SWOT analysis on Internet Protocol Security. So when we say SWOT, it is the strength, weaknesses, opportunities, and threats of Internet Protocol Security. So let's start. So first, what is Internet Protocol Security or IPsec? It is an Internet Engineering Task Force or IETF standard suite of protocols between two communication points across the IP network that provide data, authentication, integrity, and confidentiality. It also defines the encrypted, decrypted, and authenticated packets. The protocols needed for secure key exchange and key management are defined in it. Uses of IP security. IPsec can be used to do the following things. First is to encrypt application layer data. Second, to provide security for routers sending routing data across the public internet. Third, to provide authentication without encryption, like to authenticate that the data originates from a known sender. And last, to protect network data by setting up circuits using IPsec tunneling, in which all data is being sent between the the two endpoints is encrypted as with a virtual private network or VPN connection. So let's proceed in SWOT or strength, weaknesses, opportunities, and threats. So first, strengths. The strengths of IPsec is first, network layer security. So network layer security, it is an IPsec operates at layer 3, the network layer. So as a result, it has no impact on higher network layer. In other words, one of the biggest strengths of IPsec is its transparency to application. The end user need not to have to bother about the IPsec or its configuration. Additionally, as it works at the network layer, IPsec allows to monitor all the traffic that passes over the network. Second is confidentiality. Similarly, the second strength of IPsec is that it offers confidentiality. During any data exchange, IPsec uses public keys that helps to safe to transfer confidential data. As a result, security, securing the keys ensure safety data transfer. These keys help to verify that the data has come from the correct host. Therefore, it becomes rather impossible to force the data packets. And last, zero dependability on application. IPsec security is implemented at the network layer, thus it do not depend on the application used. IPsec only requires modification to the operating system. As a result, IPsec-based VPNs do not need to worry about the type of application too. That's not the case with SSL-based VPN, wherein requires modification to individual's application. This is yet another reason for the popularity of IPsec. Next is weaknesses. Wide access range. So when we say wide access range, it is one of the greatest weakness of IPsec. It is one of the wide access range, giving access to a single device in IPsec-based network can give access privilege for another devices too. For instance, imagine that you are connecting to a corporate network from your IPsec-based home network. For example, if any of the computer in your home network has malware in it, it can easily spread to the computers in the corporate network unless There are special security mechanism vulnerabilities that exist at the IP layer will pass on the corporate network across the IPsec tunnel. Second is the compatibility issues. IPsec brings in couple of compatibility issues with software too. This happens when software developers do not adhere to the standards of IPsec. Similarly, when you are already on IPsec-based VPN, connecting to the other network will be rather impossible due to restrictions in firewall. So again, IPsec does not provide support or multi-protocol and IP multicast traffic. CPU overhead. Unfortunately, IPsec is well known for the high CPU usage. It requires quite a bit of processing power to encrypt and decrypt all the data that passes through the server. When the data packet size is small, the performance of the network diminishes due to a large overhead used by IPsec. So last is broken algorithms. Security of certain algorithms used in IPsec is a concern. If someone uses these broken algorithms, server will be at a greatest risk of hack opportunities. Reduce key negotiation overhead and simplified maintained by supporting the IKE protocol. IKE provides automatic key negotiation and automatic IPsec security association or SA setup and maintenance. Good compatibility. You can apply IPsec to all IP-based application systems and services without modifying them. And last, the encryption on a per packet rather than per flow basis. Per packet encryption allows for flexibility and greater enhances IP security. Threat. Face man in the middle. IPsec VPN uses key to tag one another as we have already shown. An attacker will be able to recover a vulnerable pre-shared key inside this vulnerability. This attack just targets the handshake implementation of IKE, which is used for IPsec VPN connection. Using certain keys, link can be decrypted. It will eventually open the door to attacks by the man in the middle. This will inevitably lead to leakage of VPN sessions data. Second is password cracking. Similarly, password cracking occurs another problem with IPsec. Unfortunately, this occurs for both versions of IKE v1 and IKE v2. When a VPN user enters a password, it is encrypted by the server and then compared with restored values. The person gets entry if they match. And third, it is buffer overflow. Buffer is nothing more than a temporary place for storage. A program can sometimes forget the better location and overwrite adjacent memory location. This bug arises because of a buffer overflow in the affected region of code. So that's all guys. Thank you.